Hello friends, in this video I'd like to solve the following problem from the Brazilian Mathematical Olympiad, university level, second round, year 2010, problem number 1. We wish to evaluate the following definite integral from 0 to pi over 4 of t over cosine of t plus sine of t, everything times cosine of t in the denominator, dt. Pretty nice integral. Here are my hints. First of all, recall these two basic trigonometric identities, that 2 times cosine of t sine of t is sine of 2 times t. Likewise, 2 times cosine of squared of t minus 1 is cosine of 2 times t. Then, after noticing that, try changing t to be u over 2, and then change again u to p over 2 minus v. And also recall the following so-called universal trigonometric substitution when we are dealing with integral of some rational function composed with trigonometric functions. The following substitution works. We put u to be 2 times arctangent of x, and then it turns out that cosine of u is 1 minus x squared over 1 plus x squared, sine of u is 2x over 1 plus x squared, and du equals 2 times dx over 1 plus x squared. It's a well-known substitution. So give this problem a try, and I will see you in a minute. Okay, so here is my solution. So let's call this integral I. Why not? I is integral from 0 to pi over 4 t, and let's multiply the denominator. We will have 2 times cosine squared of t plus cosine t sine t dt. And I will multiply everything by 2, both the denominator and the numerator. And what do we have? Well, now this very same integral can be written in this way. 2t, well, 2 times cosine squared of t, it's the same as cosine of 2t plus 1, and 2 times cosine of t sine of t is sine of 2 times t dt. Okay, and since we have 2t everywhere, we can make our first substitution. First, I will let u be equal 2 times t, which means that du equals 2 dt. And what about the bounds of integration? Well, since t goes from 0 to pi over 4, u goes from 0 to pi over 2, obviously. So our integral can be written as integral from 0 to pi over 2. Well, 2t is u. In the denominator, we have cosine of u, sine of u, plus 1. And dt is just du over 2. So we can write it du over 2. Very well. Okay, and you know what? Maybe I will put 1/2 in front. u du cosine of u sine of u plus 1. Okay, that's one way to express our integral. And here is another way. Let's put v to be pi over 2 minus u. Then we have the following. dv equals minus du. And what about the bounds of integration? Well, since u goes from 0 to pi over 2, v goes from pi over 2 to 0. So our very same integral can be written also in the following way. 1/2 integral from pi over 2 to 0. Instead of u, we see that u equals pi over 2 minus v. So we have pi over 2 minus v. cosine of pi over 2 minus v plus sine of pi over 2 minus v plus 1. And instead of dv, du, we have minus dv. Very well. And well, classic trick, I can use this minus to change the limits of my integral, and I can write it in the following way: 1/2 integral from 0 to pi over 2. And what else? Well, here I have pi over 2 minus u, and now using well-known formula, cosine of pi squared over v minus v is sine of v. Sine of pi over 2 minus v is cosine of v plus 1 dv. And since our integral is a definite integral, we can change the name of the variables from v back to u. So we can write pi over 2 minus u, cosine of u, sine of u, plus 1 du. Okay, very well. If you look closely, we have two different ways of expressing I. I is at the same time this, and at the very same time it's also this. So you know what, I will, or maybe you know what, I will write 2 times I equals, well, these two integrals: 1/2 integral from 0 to pi over 2 u cosine of u sine of u plus 1 du plus 1/2 integral from 0 to pi over 2 pi over 2 minus u cosine of u sine of u plus 1 du. If we add these two integrals together, we'll have just one integral, or 1/2, because let's take a look. We have 1/2, and pi over 2, so it's pi over 4. I'm running out of space anyway, so let's write it in the next line. It's pi over 4 integral from 0 to pi over 2 just du over cosine of u sine of u plus 1. Because u is gone, here we have u and here we have minus u, so the other part is gone after combining it into one integral. And that means, because it's 2 times u, so that implies that I equals pi over 8 times integral from 0 to pi over 2 du over cosine of u sine of u plus 1. Okay, and I'll argue that this integral is simpler because we no longer have u in our numerator. In fact, we have a rational function composed with trigonometric functions, and these types of integrals can be dealt with using universal substitution. But I need a new page to do that. Very well. Now, my last substitution, as I suggested, I will put u to be 2 times arctangent of x, let's say. Well, it can be verified that cosine, I don't wish to do it because it has been done multiple times and I don't feel like reinventing the wheel. So it's 1 minus x squared, 1 plus x squared. Sine can be expressed as 2x, 1 plus x squared, and finally du can be expressed as 2 times dx, 1 plus x squared. What about the bounds of integration? Well, since u goes from 0 to pi over 2, x goes from where? Well, Well, let's see. If I put u to be 0, arctangent of x equals 0 for x equals 0, very well. And if I put u to be pi over 2, arctangent of x equals pi over 4. And we know that tangent of pi over 4 is 1. So it goes from 0 to 1. So our integral I can be written as integral, this time from 0 to 1, sorry, pi over 8 stands in front, pi over 8 times the integral from 0 to 1, and let's put everything. Du is 2 times dx, 1 plus x squared, and here we have cosine is 1 minus x squared, 1 plus x squared, sine is 2x, 1 plus x squared, and you know what? 1 can be written as 1 plus x squared over 1 plus x squared. And let's put it in the middle. Yes, very well. Now, let's simplify it. Pi over 8 times integral from 0 to 1. And here, after some simplification, we will have, all in all, we'll have dx over 1 plus x. And that's a very simple integral, because it's just natural log of 1 plus x evaluated from 0 to 1. Natural log of 1 is 0, so we have just pi over 8 times natural log of 2. And that is our answer, our integral going from 0 to pi over 4 of t. There was cosine t sine t cosine of t dt. This integral equals pi natural log of 2 over 8. And that is our answer. Pretty nice problem, I'd say. A bunch of substitutions, changing trigonometric functions via universal substitution to a rational function, and all of that. Very well. Thank you for watching, and I will see you next time. Goodbye.